Okay, hello everybody, what's going on? This is Muhammad. Welcome to another video. In this video, I'm gonna be teaching you a second way of how to solve for the unknown angle x in this particular problem as compared with the previous video. So in the previous video, I have proposed a fast and easy way to calculate for the unknown angle x. In this video, I'm gonna be proposing a different approach to solve for the angle x. So here we're given a square of unknown side length, a circle that is tangential to two sides of the square, and an oblique line that is also tangential to the circle and makes an angle of x with one of the sides of the square. So the question is to solve for the angle x. Now, given the two line segments, 3 and 2, basically the red line segment is connecting the two tangential points, and the continuation of the red line segment hits the square side length at a point. Now the remaining length is equal to 2. So if these side lengths, 3 and 2, are given, find the angle x. So if you guys are interested, again, pause this video, give this problem a try, and once you're ready, keep watching this video for a solution. So how to solve for x? So I will start first of all by letting x equals to 2 alpha. Okay, so that's the first thing that I will do. Okay, so I will assume that this angle here is equal to twice alpha. Okay, so that makes the remaining angle 90 minus 2 alpha. So I will bisect, because I will bisect, okay, this angle, the remaining angle, with a line. That line is going to pass with the pass through the center of the circle. So let me use a black color. Okay, so basically the center of the circle is is where these two perpendicular lines meet, and that is going to be the I will assume that the circle radius is equal to r, and this also is equal to r, and the line that bisects, okay, this angle here is going to pass also through the circle center. Okay, so if this angle here is twice alpha, so the remaining angle is going to be 90 minus 2 alpha. So that makes each one of those, because they are equal angles, that makes this angle here 45 degrees minus alpha, and this other angle here exactly equal to that, which is 45 degrees minus alpha. And because we know that this angle here is right angle, because the radius is perpendicular on the tangent, and also if we draw a radius here, that is also going to be perpendicular on the oblique line, because they are tangent to each other. So that's also 90 degrees, and this is 90 degrees. If this is 90 degrees, that makes this angle here 45 degrees plus alpha. Okay, and of course this angle, which is equal to that, also 45 degrees plus alpha. And we know that this is also 90 degrees. This is also a right angle. Okay, so that's 90 degrees. So that makes these three angles here equal to 190 plus 45 plus 45. That's 180 plus 2 alpha. So that makes this angle here, that makes this angle here equals to 180 degrees minus twice alpha. And because this length here is equal to this length here, because it's basically the radius of the circle, that makes this triangle here an isosceles triangle. So that makes these two angles here equal, and each one of them is equal to alpha. Okay, now if this is alpha and this is 90 degrees, that makes this angle here equals to 90 minus alpha. So this is going to be 90 degrees minus alpha. And because we have 2 alpha, so this other angle here, because the sum of the angles of a triangle are 180 degrees, so that makes this angle here 90 minus alpha. So that makes these two angles equal, and that tells us that this triangle here is an isosceles triangle. Okay, So let me erase all the highlights so you guys can follow up with me, okay? So this triangle here is an isosceles triangle, so this length here is equal to this length here as well, okay? So if we assume that the square side length is equal to, let's say, A, so that makes this remaining length here from this point to this point equals to A minus R. And because this is a tangent, and so the other tangent, because they are drawn from the same external point to the circle, so they should have equal lengths. So this is also equal to this. So this is A minus R, and this makes also A minus R because this is also an isosceles triangle since the two base angles are equal. So that makes this side length here equals to A minus R. So the remaining length, since the square side length is equal to A, so A minus R, that's gonna leave us with R here as well. I will draw from this point a perpendicular line on the other side of the square. So, but let me move it a little bit down. Okay, so that is gonna, this angle here, we know this angle is a right angle, so that's 90 degrees, and the remaining angle is 90 degrees. If this angle is 90 minus alpha, so that leaves us with an angle that is alpha here, because alpha is gonna get cancelled with alpha, and we're gonna be left out with 180 degrees, and that's it. So we know that this angle here is alpha. So we basically can benefit from this triangle in order to calculate for, okay. Let me erase again everything so you can follow up with me. Now we know that this side length here is equal to A minus R, and this is R, so the remaining length here is going to be equal to A minus R, so that makes this length equals A minus twice R. And we know that the whole side length is equal to A, of course. Okay, now I will do one thing. I will extend this line here until it hits the circle at a point. And from that point, I will connect it with this point here. Okay, so now we have an angle which is 90 degrees actually, because it faces, okay, the diameter of the circle. Okay, each one of those is basically equal to R. Okay, so this is basically R, and this is R, and this is going to be R as well. So the whole diameter is going to be twice R. Now what I'm going to do, I'm going to project this length here, which is twice R, over this red line segment through cosine, the cosine of the angle alpha. So if I multiply 2R multiplied by cosine alpha, that's going to give me the length of the red line segment, which is basically equal to 3. I will do one more thing also. So let me first of all write that equation. Okay, so twice R multiplied by cosine alpha, that is going to give us 3. Okay, now how can I get cosine alpha? Because I need to get rid of alpha here. So what I can do, we can use this. Let me again erase all the highlights. Okay, we are going to use this triangle here to calculate for anything that relates to alpha. So cosine alpha is basically going to be A divided by 5. Okay, so 2R multiplied by A divided by 5, that's going to give us 3, and from that that makes 2RA equals to 15, and this is going to be our first equation. Our second equation, so that's an equation of R and A, so the unknowns are R and A, so we need another equation to solve for R and A. How can we get our second equation? I will benefit from this an isosceles triangle here. So to benefit from that, what I'm gonna do here, I'm gonna draw a perpendicular line that is going to be perpendicular on the opposite side length. Okay, so that's gonna bisect, okay, the angle, and also will bisect the line segment, the opposite line segment. Okay, true? So this is gonna be a 90 degrees, And the whole length, the whole green line segment is equal to 2, so that makes this side length equals to 1, and this side length equals to 1. And also that's going to bisect this angle here. So this angle is going to be alpha, and this angle is going to be alpha. So what I'm going to do now, I will, first of all, erase the highlights. I will project this line segment, which is basically a minus r over the green line segment. So that's going to be through the sine of the angle alpha. So a minus r, so that makes 1, which is basically a minus r multiplied by sine alpha. Now, how am I going to get sine alpha? Again, we're going to go back to the same triangle, okay? This triangle again, to calculate for sine of alpha. Sine of alpha is going to be equal to the opposite over the hypotenuse, so it's a minus r multiplied by a minus twice r divided by the hypotenuse, which is basically 5, and that is going to form our second equation. Now we have two equations that are in terms of a and r. We can leave them as they are, and we're gonna use the the Wolfram alpha application to solve for that. I'm not gonna waste the time solving for these two equations simultaneously. So I have done already that using the Wolfram alpha application. So these are the two equations, and we have basically 4 solutions. So we're gonna pick the right solution. So we're gonna ignore the solutions that have negative values for a and alpha. So the first solution here is going to be ignored. The second solution is okay. The third solution is going to be ignored. The fourth solution is going to be ignored as well because a is too small. So basically, the right solution is going to be the second solution, which is a3 multiplied by the square root of 5 divided by 2, and r is 1/3 of that, which is the square root of 5 by 2. So let's go back again to our solution. So now we know from after solving these equations that a is equal to 3 multiplied by the square root of 5 divided by 2, and r is basically 1/3 of that, which is basically the square root of 5 divided by 2. Now, after having solved for a and r, how can we solve for the angle x, which is basically twice alpha? How can we solve for the angle alpha? What we can do here, we can project the line segment 5 over using the cosine of the angle. That's going to give us the square side length, which is equal to a. So if we multiply 5 multiplied by cosine of alpha, that's going to give us a. Where a is basically this one here. We can substitute that n. So now alpha is going to be equal to cosine inverse of a divided by 5, which is basically cosine inverse of a divided by 5 is going to be equal to the 3 divided by the square root of 10 actually. Okay, so if we solve for that, that's going to be equal to 18.43 degrees. So that's alpha, and that makes x twice that, which is equal to 36.86 degrees, and that is basically the answer to this problem. I hope that you guys enjoyed this solution, okay? And if you like this video, hit like. And don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.